Okay, we're staying in 7.4 today. Factoring using a GCF. Does anyone know what a GCF stands for? Greatest common factor. Very good. So yesterday, what did we talk about in 7.4? What did we talk about yesterday in 7.4?
Making two different equations.
Yeah. Yeah, we're solving the equation by putting each factor equal to 0 and solving those two little individual equations, correct? So we were solving polynomial equations that were already in factored form, right? They were factored for us. I was able to solve them. What was that property we used when we set each thing equal to 0? Zero product property. There you go. Zero product property. We're still going to be using that a little bit today. There's just a little bit more added to it. We're going to be factoring using a GCF. To solve a polynomial equation using the zero product property, sometimes we may need to factor the polynomial first. Yesterday they were already factored for us, correct? Today we're going to have to factor them and then solve them. Okay? AKA we need to write it as a product of other polynomials. We want to look for the greatest common factor. You'll hear me say GCF, just to shorten it, of the terms of the polynomial. This is a monomial that divides evenly into each term. So the greatest common factor is the biggest number and the biggest set of variables that go into all the terms of my polynomial. Factoring out a GCF and just factoring in general is just undoing the distributive property. You guys know how to use the distributive property, correct? So instead of multiplying something through a set of parentheses, we're going to be given that final product, and it's going to want us to undo it and get those factors that you would multiply and you would distribute. Okay? So I feel like it makes a little more sense when we're doing examples. So is everyone okay if I move to the next example? Factor out the greatest common monomial factor from 4x cubed to the fourth plus 24x cubed. 4x to the fourth plus 24x cubed. It wants me to factor out the greatest common monomial factor. Do we all know what a coefficient is? What's coefficient? Not x. That's a variable. What? No, those are my exponents. 4 and 24. Coefficients are the numbers times my variables. Okay? So the first thing I need to do when I'm looking for my GCF is look at my coefficients. So what are they here? 4 and 24. I'm looking for the biggest number that goes into both of those numbers at the same time. 4, right? If you ever can't figure it out, you can always list out the factors of 4 and the factors of 24. Be 1, 2, and 4. 1, 2, 3, 4, 6, 8, 12, and 24, right? What's the biggest number they have in common? 4. So 4 is my GCF of those two coefficients. So I'm factoring out a 4. Now I got to look at the variables. How many terms do we have here? 2. So in my first term, how many x's do I have? 4. It's x to the fourth, right? Okay, in my second term, how many x's do I have? 3, because it's x to the third, right? So how many x's do those two terms have in common? At least how many do they both have? 3. Right? They both have at least 3, right? Do they both have at least 4? No, because this one's got a max of 3. So I'm really only as strong as my weakest player here. Right? So I can only have the amount of my smallest exponent, because I can't have more than that smallest exponent because there's only the amount of that smallest exponent. So how many x's do we have in common? 3. So I can factor out 3 x's, or x to the third power. 4x to the third is my greatest common factor. Okay? like I said, we're doing the reverse of the distributive property. So what I'm going to call this next step is called undistribute. We're going to call it undistribute. We're thinking about the distributive property in our head while we're doing this. I got to get something in the parentheses. That way, if I were to multiply my 4x to the third through the set of parentheses, I get back to my original problem. Okay? So we're going reverse of distributive property. So, 4 times what would give me 4? 1. Okay? How many x's does this first term have? 4. How many am I distributing through? 3. So how many more do I need to get it to x to the 4th? 1 more, right? Do I need that 1 in front of the x? No, I don't. What is 4x to the 3rd times x? 4x to the 4th. We add the exponents when we multiply with the same base, right? Is that the first term in my original problem? Yep, so I got the first term in my parentheses. Everyone okay with that? Now I got to get the second term. So 4 times what would give me 24? 6. How many x's are in the second term? 3. How many x's am I distributing to it? 3. So how many more do I need to get it to 3? None. Here's my answer. That is factored form of the polynomial that I was given. Does everyone see how it's just the reverse of the distributive property? Look for the GCF first, and then you undistribute. Okay? I know this is the greatest common factor because, well, what's the coefficient in front of x on my answer? Nope, in front of x. Nope, in front of x. Just the x. 1. Sorry if someone was saying that. Thought I heard it maybe, but maybe not. There's a 1 in front of that x, right? And then my constant is 6. Are there any numbers besides 1 that go into 1 and 6? No, so I can't factor anything from those. Do they have any x's in common? No. So when I can't factor anything else from that polynomial in the parentheses, I know that I've got my GCF outside the parentheses. Okay? Are there any questions on this first example for today? We good? Let's do another one. Factor out the greatest common monomial factor from 8y squared minus 24y. 8y squared minus 24y. I want the GCF. So, do we look at our coefficients first or our variables? Coefficients. What are my coefficients here? 8 and negative 24. So what's the biggest number that goes into both 8 and negative 24? 8, right? 8 goes into both of them. So I'm going to factor out an 8. We okay with that? Okay, how many y's does my first term have? 2. How many y's does my second term have? 1. So how many y's do we have in common? 1. So how many y's do I factor out? 1. I can only factor out the amount that they have in common. So 8y is my GCF, correct? Now we've got to undistribute. So 8 times what will give me 8? 8 times what will give me 8? 1. How many y's do we have in that first term? 2. How many y's are we distributing? 1. So how many more y's do I need to make it y squared? 1 more. So I'd get 1 y to the first or just y. You okay with that first term? Okay. 8 times what will give me negative 24? Not 3. Negative 3. How many y's are in that second term? 1. How many y's am I distributing through? 1. I'm distributing that 8y, right? So there's 1 y there. So how many more do I need to get it to just the 1 y? 0. I just leave it as negative 3. Are there any numbers that go into 1 and negative 3 besides 1? No. Do they have any y's in common? Nope. So I know I have the GCF. Questions on our second example here? We're still good. Yep.
If there was a number that went into -3, what would we put in?
Oh, you would just have to pull it out and multiply it by the 8. That means we would not have gotten our GCF at the beginning. Does that make sense? Can I move on? Different set of directions here. It wants us to solve these equations. Solve, letter A, 2x squared plus 8x equals 0. So this is where yesterday's lesson comes into play. Yesterday, that was factored for us, correct? Is that factored? No, it's not, is it? I've got common things in there. I got a common factor that I can factor out. So what do you think I need to do first?
Do what we did above.
Do what we did on the previous slides. So factor out a GCF. And then from there, I'll use my zero product property like I did yesterday to solve the equation. So this is where we're combining today's lesson with yesterday's. Okay? So let's factor that first, letter A. What's the biggest number that goes into 2 and 8?
4. 2.
2. 4 does not go into 2. It's okay. Okay, how many x's do we have in common? 1, right? The first term has 2 x's, but the second term only has 1. So I only have 1 x in common between both terms. Does that make sense? Okay. So 2x times what would give me 2x squared? X. Okay, there. 2x times what would give me 8x? What is it? Just 4. Very good. Did I pull out the GCF? Yeah, no numbers go into 1 and 4 besides 1, and they do not have any x's in common, so that is now factored. Okay with that? Now this looks like yesterday's problems. I've got one side of my equation as a factored polynomial. The other side of my equation is 0. Someone remind me from yesterday, where did I go from here? Yeah. Yeah, so what's my first equation? 2x equals 0. Next one? X plus 4 equals 0. I take each factor. This is factored form, right? So these are two factors here. Take each factor, set them equal to 0. Now I can solve these two equations for x. 2x equals 0. How do I get x by itself? Divide by 2 on both sides. X equals 0. There's one of my solutions. X plus 4 equals 0. How do I get x by itself? Subtract 4 from both sides. X equals -4. Very good. Now let's check this in our heads real quick. Plug in 0 first. What's 0 squared? 0. What's 2 times 0? 0. What's 8 times 0? 0. What's 0 plus 0? 0. Does 0 equal 0? Yeah, it checks out. We're good with that one. Okay, plug in -4. What's -4 squared? 16. What's 16 times 2? 32. What's 8 times -4? What? No. -32. What's 32 plus -32? 0. Does 0 equal 0? They both check out. Questions on letter A? You good with that? Can I erase and move to letter B? Letter B. 6n squared equals 15n. What do I need to do? Say it again. That's my ultimate goal when solving this equation, yes. But how do I do that given the equation that I'm given? 6n squared equals 15n.
See which one's the biggest number.
So you're saying find the GCF? Well, they're not on the same side of the equation, so I can't do that right now. So what would I need to do here?
Make them into equations.
No, not divide by 6.
Do you take 2 out?
Not quite. I kind of gave y'all a hint whenever I answered her question. She said her first thought was to find the GCF, but I said, oh, they're not on the same side of the equation, so I can't do that right now.
So make them on the same side.
Making a negative equal to the other side.
Which one?
6n squared.
You can do 6n squared. I'm going to do 15n. I like my leading coefficient to be positive. 6n squared would work as well, though. I'm going to subtract 15n from both sides. Can I combine 6n squared and negative 15n? No. Remember, we're trying to use the zero product property here. In my original equation, did I have 0 anywhere over there? No. But now that I got everything to the same side, do I have 0 on one side?
Yes.
Yes. So this looks very similar to letter A now. So now what do I need to do? Factor out my GCF, and then undistribute, and we'll solve using the zero product property. So what's the biggest number that goes into 6 and negative 15? 3. How many n's do our terms have in common?
2. 1.
What is it? It's just 1. My first term has 2. My second term only has 1, so they only share 1 n together, correct? So 3n times what would give me 6n squared?
Oh, sorry.
2. Is that it? Oops. Yep, because 3 times 2 is 6. If I'm multiplying 2 n's together, I add the exponents. What's n times n? N squared, so I'd get 6n squared. Okay with that one? Okay, 3n times what would give me negative 15n? Negative 5. I still have that equals 0. Are there any numbers that go into 2 and 5 besides 1? No. Do they have any n's in common? No, so I know we got the GCF, right? Okay. So what do I need to do now?
2n minus 5 equals 0.
Okay, 2n minus 5 equals 0. What else?
3n equals 0.
3n equals 0. 3n equals 0. How do I get n by itself? Divide by 3 on both sides. What does n equal? 0. Okay with that one? 2n minus 5 equals 0. What's my first step? Add 5 to both sides. We get 2n equals 5. 2n equals 5. You're jumping ahead a little bit. Now how do I get n by itself? Divide by 2. N equals 5 over 2. Now if I plug both of those in, I do get true statements, so they both are solutions to my equation. Are there any questions about my last example here? Did we understand it as we were going through it? Factoring out a GCF. There are other methods of factoring. We're not always just going to be using a GCF. We're going to be learning about those in the coming days. Okay? Can I move on?
When do we test?
Pages 365 through 366. Numbers 25 through 38 all. Get it written down. Pages 365 through 366. Numbers 25 through 38 all. Are there any questions about my notes before I end them?